Alrighty, yes, welcome to Module 4, Lesson 18, Counting Problems. And this is the last lesson in the last topic in Module 4. So yes, today we celebrate the end of Module 4. Always nice to come to the conclusion of a module. So yeah, we'll be doing counting problems today. A lot of these, or most of what we'll be doing, will require pretty much no formulas, just some basic knowledge of how to come to a percent and how to use percentages to solve counting problems. Yeah, so this proves to be a very short lesson, so I am excited. Okay, based on all of the pages I put on here, it should be very short and very quick. So with no further ado, let's move on. Okay, here's our opening exercise. Okay, we'll just jump right into it. You are about to switch out your books from your locker during passing period, but forget the order of your locker combination. Okay, explain some of these things to you, since most of you have never been to a junior high or high school. Of course, not a high school, but a junior high. Passing period, I guess, just makes common sense. It's the period in between classes and the time that you get to go to your locker and get your books, switch your books out, put your makeup on. Just kidding. No, I'm not kidding. Actually, grab a snack or whatever. Not a lot of time, but anyway, that's what a passing period is. Okay. All right. So you know that there are the numbers 3, 16, and 21 in some order. Okay, here's the question. What is the percent of the locker combinations that start with 3? Okay, and in this case here, they've listed those locker combination possibilities. There they are. I'm going to pause. I would like you to come up with a percent, and which percent or what percent of the locker combinations start with 3. Starting off with something pretty easy, and you can get a feel for what this lesson's going to be. Lots of fun and not heavy at all. So go ahead and I'm going to pause. Go ahead and give me a percent of the locker combinations that start with 3, and I'll be back. Okay, so here we go. What percent of the locker combinations start with 3? That's our focus. Well, if we go ahead and look at, we have 2 possible locker combinations that start with 3, all right, and that would serve as our numerator. That's the number of possibilities, okay, and we have 6 different possibilities, and that serves as our whole, okay, the number of possibilities, 2 out of 6, which is equal to 1 over 3, which is equal to 0.333333 and on, which is equal to 33 1/3%. Again, just emphasizing those times when we use that, decide to use a fraction as in our percentage is when you have a repeating decimal such as this one. Okay, well, that was light fare. Hopefully everyone got that, understands. If you didn't get it, maybe now you understand what we are about to embark upon. Some real light fare, I think, for many of you. Okay, here's our next example 1. Okay, so all of the 3-letter passwords that can be formed using the letters A and B are as follows. Okay, and they give them to you here. All right, we have AAA, AAB, ABA, ABB, BAA, BAB, BBA, BBB. Yes. Anyway, there they are. Okay. 2 questions. A, what percent of passwords contain at least, very important determination, at least 2 B's. Okay. Why don't you go ahead and do that and come on back. Okay, here we are back, and I counted 8 possibilities. That will serve as my whole or as my denominator. Okay, 8 possibilities. 4 of these actually have at least 2 B's. As you can see, they're ABB, BAB, BBA, and then BBB, which has 3 B's, but 3 is at least 2. Okay, so you see why at least 2 was very important. If it were 2, I could ask you how many possibilities would that have been? Okay, that would have changed, right? Okay. Anywho, let's go. We'll just continue on. So we have 4 out of 8 possibilities, which equals 1/2. And cut to the chase, we know that is 50%. Okay? All right, next one. Oh, boy, this is moving along. Only 5 minutes, 48 seconds gone by. What percent of passwords contain no A's? Okay, there we go. I'll pause. You complete and come on back. Okay, so let's go look at it. Look at no A's. Well, there's only one possibility with no A's, and that's that last one up there, BBB. And that was one possibility over 8, and hopefully 1/8 is becoming a fraction that we are familiar with, and that equals 0.125, which equals 12.5%. Okay, there we go. If you have any difficulties on this, again, of course, you'll get more practice coming up, but always just pick up the phone. But I think most of you, if not all of you, will have a real fine time with this material. Okay, so now we're going to use 4-letter passwords now. Okay, 4-letter passwords. All right, so now we have. Actually, you know what we have here is okay, I don't know if you can see this. I'm having trouble seeing, but the question here is how many 4-letter passwords can be formed using the letters A and B. Okay, how many 4-letter passwords can be formed using the letters A and B? Okay, so we're going to go ahead, and the first thing we need to do is to write all these possibilities out. I will let you get started and get as many as you can, okay, and you may indeed miss a few, but that'll be okay because I will be here to fill them in for you. Okay, so go ahead and do that. Again, 4-letter passwords that can be formed using the letters A and B. Just to give you a hint, of course, first one would be, or could be, A. All right, is 1. Okay, so how many 4-letter passwords can be formed using the letters A and B in all different positions, of course, with the A's and the B's. So go ahead and do that, and come on back. All right, so here we are back, and let's take a look at all the possibilities. How many did you get? And here they are. I'm going to write them out for you. First one, B, okay. I have 1, 2, 3, 4, 5 so far. You can see I've used all those A's. Just trimmed down the number of A's and made way for the B's. That's 5, 7, 9, 10, 11, 12, 13, 14. Now I got to 14. I was pretty good at 14, but then I was 15 and 16 I had to grapple with a little bit. And there is 15, and there is 16. Yes, indeed, there were 16 different 4-letter passwords that can be formed with the letters A and B. Okay, 16 different passwords. So hopefully you got that. If you didn't, just go ahead and write all of those down. Just pause right now and write those down. Okay, and then after you do that, go ahead and answer these questions. What percent of the 4-letter passwords contain? As you can see, A says no A's, B exactly 1 A, C exactly 2 A's, D exactly 3 A's, E exactly 4 A's, and then F the same number of A's and B's. Okay, so go ahead and do all of those. Have fun. Come on back. Again, your answer should be in the form of a percent. Okay, and come on back and we'll check them all. Okay, so let's get to it. Yeah, percentage with no A's. 1 out of 16, 0.0625 or 6.25%. Again, a good one. Now it's good to know your these unit fraction equivalent percentages. So you know now that 1/16 is the same as 6.25%. Good thing to know. Here we go. Exactly 1A. 4 out of 16, 1/4, and we all should know that is 25%. Exactly 2 A's, we had 6 out of 16, and that was 0.375 or 37.5%. And of course you can see our 16 has been our denominator the whole time, makes a lot of sense, but of course that could change here. We did this here, we just simplified there. All right, 4 out of 16 for exactly 3 A's is 1/4 again, 25%. And then the same number of A's and B's was 6 out of 16, which is 37.5%. Okay? And did we do all those? There's A, B, C, D, E. Did I miss one? I feel like I might have missed one. Let me just see here. I'll be right back. Okay, well, I'm back. Excuse me. I'm sorry for clearing my throat all the time. I do these things in the morning sometimes. I always have this little bit of throat clearing that needs to be done. Anyway, so sorry. I had actually miswritten one. I had written one incorrectly. I don't know if you guys picked up on that, but I had a double. I had actually left out this one here, this BAAA, which was really throwing me off as I was looking at this over again. And I had written it as something, I think I had written it as AABB again or something, whatever it was. But now this is correct. Okay, so, and the one I did forget to do down here was actually this one, the 4 A's. Okay, the 4 A's was actually 1 out of 16, which is 6.25%, as we've seen a couple times here. Okay, so that's what that one is right there. So you can just pause this and just take a look at it, and maybe you have already, and just see how you did. Okay, so there we go. Let's move on. Okay, so next here we have a series and a set of 3-letter passwords. Okay, so in a set of 3-letter passwords, 40% of the passwords contain the letter B and 2 of another letter. A little bit difficult to understand, but let's talk about it a little bit further. Which of the 2 sets below meets the criteria? I love this kind of problem. And explain how you arrived at your answer. This is a really this is a lot of fun. This kind of problems you do. It's kind of a mystery of sorts. Okay, so now you're kind of working backwards. You know 40% of the passwords in one of these sets, either set 1 or set 2, is going to contain the letter B. Okay, so that's 1B and 2 of another letter. Okay, so those 2 have got to be the same. Okay, they've got to be the same. I think I make note of this. Yeah, same letter pair. Okay, so it's going to be like a similar letter pair along with a B. Okay, so why don't you go ahead and do that investigative work. Okay, find out what percent of set 1 and set 2 meet those criteria, and come on back and we'll check. Okay, so let's go ahead and check. I'll show you what I did. I started with set 1, and that was kind of an opportune one to start with, because what I did is I first highlighted all of those trios, 3-letter passwords that actually met the criteria. They had a letter B and then a pair of another letter. Okay, so you can see CBC fits that criteria. AAB does, ABA does, CCB, BAA, and then BCC all fit the criteria. Okay, and there were 6 of those, and there were 15 total trios in set 1. So 6 out of 15, same as 2 out of 5, which we know to be 40%. I have my answer already. Okay, if I'm going to explain how I arrived at my answer, I pretty much have done that just by the work I've done here. So, I mean, how do you explain it? Yeah, you took the way you explain it is you took the number that met the criteria, divided it by the total number of possibilities to get the percent that meets the criteria. And there we go. There we have it. Nothing else to say. Okay, but for you, I'd like you to try to become more comfortable with writing those explanations down. Okay? All right, well, let's move on. No, I guess we won't move on. I'm sorry. I just wanted to prove or disprove that, or just prove that set 2 did not work, because who knows? Maybe it will. Okay, there are the 3 of the 3 of the 10 in set 2 that met the criteria. So that was 3 over 10, and that was 30%, which is not 40%. Therefore, set 1 is the winner. Okay? All right, so here we go. We have our next problem. So Shauna read the following problem. How many letter arrangements can be formed from the word triangle that have 2 vowels and 2 consonants? So order does not matter, okay? She answered, and again, you don't have to do all this work, okay? She answered that there are 30 letter arrangements, okay? So Shauna's done all this work here. 30 letter arrangements. Now, 20% of the letter arrangements that began with a vowel actually had an English definition, okay? And we could probably look at that right now. I mean, the word angle, for example, starts with a vowel, and it has an English definition, so that would have been one of those. But 20% of these letter arrangements, okay? So just keep that in mind. And the question we're asking here is how many letter arrangements that begin with a vowel have an English definition, okay? I'm not going to tell you what numbers you need to use. I just want you to go ahead and figure it out yourself. Come on back when you have the answer to this question and some work done, and we'll check it. Okay, so using Shauna's figures here, there are 30 letter arrangements that she figured. Okay, so 30, that becomes our whole. That's our possibilities. 20% of those letter arrangements that begin with a vowel actually had an English definition, and we're trying to figure out how many that would have been. Okay, now we're not using a percentage as our answer, but an actual number. Okay, and what do? We go ahead and apply that 20% and multiply it times our 30. Okay, this is more or less the Q equals P times W formula coming into play, and that equals 6. Okay, so 30 times 20%, or 0.2, which is the same decimal equivalent, equals 6. So 6 of those letter arrangements that began with a vowel using the word triangle have an English definition, and I think this would be a lot of fun to actually figure them all out. Actually, here's what I'm going to do. We're only 18 minutes in, and there's only a few more pages to go, so why don't you take a little time, if you want to, and see if you can find some other English words with definitions that you can make from the word triangle if you feel like taking a few moments to do that. I'm going to go ahead and do that myself right now, and I'm going to write them down, see if I can get to 6, and then you come up back and check it, and if you don't feel like it, just move on past. Well, here are a few I got, and I've just been sitting here for 5, 6, 7, 8 minutes, and I don't have the patience to actually complete these yet. I'm going to go ahead and I'll do those later and maybe come back and show you what I had. Anyway, we can do that, and might be something to show at the end. Okay? All right, so here we go. Let's go ahead and move on here. We have our next, number 4, using 3 different keys on a piano. A songwriter makes the beginning of his melody with 3 notes, C, E, and G. Okay, and they give you the list of the possibilities there using 3 notes, 3 different keys on the piano. All right, so there they are. You can count them. Oh, darn, just went ahead and did that for you. Anyway, from the list above, what is the percent of melodies with all three notes that are different? Okay, all three notes that are different. I think you saw that. Maybe you could always rewind and see it, huh? Anyway, I want you to go ahead and do A and B, okay, and then come on back and check your answers. Alrighty, so go ahead and do that, and see you in a second. Okay, so here, example 3, we're going to go ahead and look at these 36 points on this coordinate plane. You can see all of those little red dots are the points. There are 36 of them with whole number coordinates between 1 and 6 inclusive. Just to let you know, so there's no confusion, this is a coordinate plane, so therefore all of these have number values. Of course, they're not plotted here. They're not written here. I don't exactly know why. But they weren't written, so just have to assume that they are there. Okay, so I'll just get rid of those now because they might get in the way eventually. All right, just so you know. And the first task here is actually, I don't know why that happened, but let's just see. Okay, so the first task, no, it's not that one. All right, so the first task here is you're going to go ahead and draw a line through each of the points that have the x coordinate and y coordinate sum of 7. Okay, of 7. And what that's going to mean, I'll just show you with an example here. For example, right here, 6. The point 6, 1, which is right here. Okay, which looks like this if we put it in parentheses. 6, 1. That has a sum of 7. Okay. Another point would be 5, 2. You can see that. Here's 5, and here's 2. Okay, that's that point right there. That also has a coordinate, has a sum of 7. All right, so that line is going to look like that, something like that, if it were done nicely. Okay, so your task here is to go ahead and do that for all of these different sums. 6, 5, 4, 3, 2, 8, 9, 10, 11, 12. Okay? So there's going to be a bunch of lines on here, and you can imagine where they're going to be probably right now. But go ahead and do that, and come on back, and we'll finish this up. Okay, so let's go ahead and finish this up. If at any point during this explanation here, our presentation right now, if you notice you did something incorrect, let's go back and fix it. Okay, so here we go. So we did the x coordinate and y coordinate with a sum of 7. That's that line there. Okay, and there's that 7 up there, you can see. Now we're going to do x coordinate and y coordinate sum of 6. I just went ahead and drew those numbers in there, and that was the one there. That was the one that were equal to they were a sum of 6. You can see, for example, the point 5, 1 right here. Right. Next was sum of 5, which is right there. Sum of 4, sum of 3. I forgot to fill those in. There we go. Sum of 2, right there. Okay. Sum of 8, sum of 9, sum of 10, sum of 11, and then sum of 12. Okay. So your graph would have looked something like this, with a bunch of lines. Mine are not necessarily perfectly straight, and yours might not be either. Hopefully you used a ruler, so we can practice using that ruler for some nice lines. Okay, so now we're going to use that, we're going to go ahead and use that graph that we just made all those lines on to answer the following question. So what percent of the 36 points have coordinate sum 7? And that would be very simple. All we need to do is count those points that were on that line that we drew, that first line actually, and there were 6 of them, okay, and there were 36 total points, okay, because we know that because that's right here. All right, so 6 out of 36, same as 1 over 6, which is 16 2/3%. 16 2/3%. All right, and now we're going to write a numerical expression that can be used to determine the percent of the 36 points that have a coordinate sum of 7. All right. not exactly sure why this question is in here, but that would look like 6 over 36 times 100, okay? And again, why the times 100? Well, we have not been doing this throughout. I have not taught you this way. I just wanted you to recognize. So if I did 6 over 6 over 36, okay, what comes out of my calculator looks something like this, 0.166666, okay, and on and on and on, all right? That's what comes out. But what I've just taught you, and hopefully you recognize that you just need to go over a few places there to get your actual, and again, I'm just using, that'd be something like that, or of course I've taught you to do 16 2/3% when you have the repeating 6 or the repeating 3. But with the timesing by 100, I think you might recognize, if you go ahead and just do this in your calculator, once you multiply by 100, what it does is it moves that decimal point over 2 places, which are, of course, the result of the 2 zeros. All right. So by multiplying by 100, multiplying the answer to this fractional division, so 6 divided by 36 times 100 is going to give you 16 on your calculator, 16 point something like this. Okay, it's going to actually do that moving by itself. And again, it makes a lot of sense because percent, of course, means per 100, and therefore multiplying by the 100. Okay, so for some reason they've decided to slot that into this lesson, okay, without really much explanation, but just wanted to show you or just tell you why that was happening, okay, why that 100 was there. Okay, now we have back to our percent problems here. What percent of the 36 points have the coordinate sum 5 or less? Okay, again, probably a little practice in reading a problem, paying attention to a problem closely. Yeah, 5 or less. Okay, and that would have been 10. There were 10 of those. And then 10 over 36, or 10 divided by 36 times 100 is 27 7/9%. Okay, 7/9%. Ninths give you a very interesting little decimal. 1/9 is actually 0.111111, kind of cool. Okay, and then 7/9, of course, would have been 0.77777. All right. So anyway, that's where we got this 7/9 from. Okay. And all right, let's move on. Last one here, this E. What percent of the 36 points have coordinate sum 4 or 10? Again, kind of getting you used to these ideas. We're going to be talking about probability and statistics next in Module 5. Very important, the words and or. Okay, they mean very different things when it comes time to talk about probability. And or are very specific procedures. So right here we have a little practice with that word or. Okay, so 4 or 10. Okay, and go right there. 6 over 36 times 100. 16 2/3% would be that percentage. For 4 or 10. Okay, one or the other. Okay. All right. Well, there we go. Here we are. 29 minutes at the end. Lesson summary. So what we learned here is well, you might have known already, but to find a percent of possible outcomes. Talking about possible outcomes. Again, this is a nice little segue, this lesson, into Module 5, which talks about, like I said, statistics and probability. But to find the percent of possible outcomes for a counting problem, not sure why they said counting problems, but anyway, you need to determine the total number of possible outcomes first, okay? Very, very important, what your denominator is going to be, or your whole, or your total, and the different favorable outcomes, okay? The outcomes that are going to satisfy you, okay, for whatever purpose you're talking about. And again, in the next module, we will talk more about that in the statistics world, okay? The representation, quantity equals percent times whole, okay, can be used, where the quantity is the number of different favorable outcomes. Okay, so that would be the Q. And actually I should say, I should adjust this here, just so you can, if you're going to write notes, but this is different favorable outcomes. And that's a big difference. Okay, that's going to be the number of different favorable outcomes, and these favorable outcomes are the ones that we're looking for, that serve our purposes, whatever they may be, whatever statistical venture or quest we are on. Okay, and that's going to equal some percentage times the total number of possible outcomes. Okay, and that total number of possible outcomes, that's kind of where we start from. All right, and then the percentage is the percentage that will relate to the different favorable outcomes. Okay, so anyway, yes, a good segue. It's a good way to end this module. Just thinking ahead towards the next module. Okay, so your task right now is to go ahead and do that practice test in the practice end of module in your binder, and be ready for a second version of that in class. All right, so good luck with all of this. Good luck with your problem set. I hope you enjoyed this very, very short presentation. I know I did.